Hello, my lovelies. It's Susanne, and today I want to show you step by step how to calculate this integral here. We have the integral from 0 to 1, e to the power of the square root of x over the square root of x dx. This integral is not so easy to find immediately, so we cannot just say the antiderivative of this function is the following. We have to use one of two methods, either the method of substitution to solve this more complicated integral, or there is a second method called integration by parts. And we have to make the decision now whether we're going to use this method or this method. Only one of them will work. So sometimes you choose one method, you try it, then you see it doesn't work at all, and then you have to go back to the other method. But to avoid this, there are some clues that you can take a look at. Integration by parts, for example, you usually use it if you have a product of functions. So x times e to the x, for example. Do we have a product here? No, we have this fraction here, but this actually doesn't mean that this method won't work, because sometimes you have functions like, for example, ln of x over x, which is a fraction, but you can write this fraction as a product. And in this case, actually, then if you convert it into this product, then you really use integration by parts to solve this integral here. So the fraction itself doesn't tell us a whole lot, but substitution is usually used if you have a function inside another function. So here we have the square root of x inside our exponential function. So we don't have just e to the x here. No, we have the square root of x here. So we have the square root function inside our exponential function. And every time this happens, substitution looks pretty good, so we're going to try substitution here in our case. And there are 5 steps that you can use for substitution. Step number 1, substitute u with something. So we have to substitute the thing that makes this function here the most difficult, or that disturbs us the most. And we already said it would be nice if we just had e to the x here. We don't have it. So what disturbs us the most is this square root of x. So I want to substitute it and make my function easier. So my u is going to be the square root of x. This was the first step. Substitute. Second, adjust the limits. Okay, so we have limits here. If you don't have limits in your integral, then you don't have to do anything, so you can just skip this step. But if you have limits, we have to adjust them now, because these limits belong to my x here. But because we're going to substitute x by u, we need u limits now. So we need new limits that belong to my u then. We just take the old limit, so let's start with a 0, and insert it here for our x, because they belong to x, and find our new u limit. So we have the square root of, and instead of x, we're going to insert 0 first. The square root of 0 is just equal to 0, so this is my new limit here. Well, new, it didn't really change. Usually it changes, but this time it just didn't. Okay, happens sometimes. And the upper limit, the same thing. We take the 1 and insert it here. So my upper limit then is the square root of 1, and the square root of 1 equals 1. So this is my new upper limit. Okay, also this didn't change. Not a good example here. Usually they change. But we adjusted the limits. So this was step 2. Step 3. Find du over dx. Okay, so far we adjusted the limits. We have our substitution here, and now they want us to find du over dx. What is this? Some people might be confused maybe to see this. Other people always work with this way of writing it. This is just the mathematical way of writing u prime of x. So you can write the derivative of u either like this or like this. It's the same thing. The thing is that we need this way here now because it helps us a lot. We won't use this way of writing u prime, but keep in mind that this just means that you want to find u prime, so that you want to differentiate this function here. Okay, I delete this again, and we want to find the derivative of the square root of x. This derivative actually is one that is really worth it knowing by heart. So if you want to differentiate the square root of x, then you can just say it's 1 over 2 times the square root of x. Because if you don't know it by heart, then you have to write the square root here as x to the power of 1 over 2, and then use all the rules, simplify it, and then in the end you end up here. But it's a long way, so I would really recommend having this derivative in your head. But this was all we had to do in this step, so just find du over dx. We have it now. So this was step 3. Step 4, solve for dx. Okay, now that we have this equation here, we have to solve this equation for dx. First we have to get this dx out of the denominator, so let's multiply both sides of the equation by dx. It cancels out here then, and we only have du left. On the other side, we have all of this beautiful stuff here and times dx. We still want to solve for dx, so we have to get rid of this fraction here. We can multiply by this denominator, so times 2 times the square root of x on both sides of the equation, of course, so that on the left side we have this expression here, and on the other side this cancels out and only dx is left. And this was what we were supposed to do to solve for dx in this 4th step. And we take a look at the last step. Replace in the integral. Okay, so now that we've done all this work, we are going to use our substitution and our dx here to replace these things in our integral. Okay, let's start. We had e to the power of, and this here was where we were like, we don't like that we have a function inside another function, so we wanted to replace this by our u, and now is the time to do it. So instead of the square root of x, we're going to write down just a u. Then we have over. And then there is more than just this function inside the other function. So if you have more parts with x or more numbers, just write them down in your integral. They will disappear soon, so just trust the process. We don't have to replace this here, so we just write down the square root of x, only replace your stuff where you had these compositions of functions. We didn't have it here, so that's fine for now. And instead of dx, we're going to write down what we figured out here. So we have 2 times the square root of x, and then our du at the end. Now, this is our new integral. It still looks pretty complicated, but we haven't simplified it yet, because now can you see that we can cancel this and this out? There is nothing with x here anymore. We only have our du here and our u here. So we're going to solve this u integral now in the limits from 0 to 1. E to the power of u times 2. I'm going to write down the number first so that we have 2 times e to the power of u, and then our du at the end. And now we only have to solve this cute little integral. We can find the antiderivative immediately. First, our limits from 0 to 1. But to find the antiderivative, we have 2 times, so the 2 times just stays the same. And e to the power of u also just stays the same. So we are lucky here, nothing changes. This is our antiderivative. And now, because we have limits, let's insert them. First, the 1. For every u that you can find in here, we're going to insert 1. So we have 2 times e to the power of 1. Then always a minus, and then the same thing with this limit here. So we have 2 times e to the power of, and instead of our u, we insert the 0. Let's simplify this. 2 times e to the power of 1 is just e, minus e to the power of 0. Something to the power of 0 is always equal to 1. So we have 2 times 1 here, which is just 2. And this is the value of our integral. And just in case you don't have any limits here in your integral, and you end up here at the end, and you want to know, what do I do with this now? How can I find my antiderivative? At this point here, first of all, you would have to add this constant c. Don't forget that. But here, instead of your u, you're going to replace it now again by what it was. So it was the square root of x. So your antiderivative in the end would be 2 times e to the power of, and instead of your u, you take the square root of x again, and then don't forget the constant c at the end. But this would be your antiderivative. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!